right, welcome back. We are working on learning how to code, or rather use Python in Poser to do things. So far, what we've learned how to do, if it's been a while and you've forgotten, is we've made a dialog box. And it says if we type, it prints. If we type, it prints, including the typos I make. Okay, so that's what we've got so far. That doesn't have too much to do with Poser, except for this really awesome, easy way of making that messaging box. We really haven't accomplished anything. We haven't done anything to our scene so far, even though we do have, excuse me, we do have, some stuff related to figures and poses, but we haven't done anything yet. So I'm going to do a couple things. We'll leave that variable. We may want it later on. We're going to get rid of that other line. So let's go back to our steps that we wanted to follow. So we've done this one, and now we want to find the materials on the figure. The figure is here. We chose it earlier. And that's going to be whatever figure we have selected in the scene. So now that we have that figure, how do we find the materials? It's actually not that hard. Again, this is one of those things that Poser has given us. Now I'm going to create a definition, and the reason I'm going to do this is because I don't just want a lot of loose stuff, and we may want to do this in a different way. We're going to create a definition. I'm going to call it cycle through nodes. And that's because this is probably going to end up being a combination of these two things. We'll see exactly where we end up. And so we're going to cycle through nodes, and this is going to take some input. No, you know what, I lied. At this point, it's not going to take anything. We may add that in later, and we'll see where we end up there. Again, I want you to see how to think through the coding, because it's not a linear process always. You are going to jump back and forth. You're going to think you want things set up one way, and then realize you want it set up another way. So, here we go. I have this new definition, cycle through nodes. So we have a figure, and we want to know what the materials on that figure are. So I'm going to declare a variable called materials, and we're going to set that equal to figure.materials, because, oh, is it material or materials? Okay, come on, Poser reference manual. Pretty sure it's material 1. Let's see here. Does this look like, oh, get a list of materials. Okay, perfect. Materials. We'll see. Actually, we're going to find out in a minute if this works. So if we do this, let's see what this does. Let's see what we actually get, because again, it says get a list, so that's kind of useful, and it says something about a list here. But what does that mean? What does that look like? So we're going to do a print statement. Print statements are our friend, and we're just going to see what happens if we try and print materials. Now, at this point, our code is really asking us for input, and we haven't gotten to the cycle part. What I'm going to do is, I'm not really interested in the input part. We're going to want that back later. I am just going to call cycle through nodes for the moment. And so I'm going to save. And so we're going to use this because I don't want to deal with typing an input. It's pretty cool, but we're trying to do other stuff right now. So we're going to run our script. And okay, so we got some gobbledygook again. When I say gobbledygook, that's a very technical term. I was trying to see if I could get this. That's almost formatted nicely. So material object at this. I am going to let you know a little background knowledge. This is what's called a memory address. This is sort of where the computer thinks it at. This is a look at what the computer's got going on in its brain. We aren't going to use this stuff directly. We're not going to try and like find 0 by 1217, so on, but it is useful. And that is a reference to the actual materials. Now, what if we do this though? But that doesn't really tell us if we've got the materials we want. If you remember earlier, we did figure.name. And actually, we're going to print figure.name. And when we do this, and we run our script, we're going to get almost the same stuff. So up here we get this nice pretty DK Stola v4. That's pretty readable. And then we still get the gobbledygook. So what we're going to do then is, well, what happens if we do name here? Now this I don't believe is going to work. We will see. But I don't expect it to. And, there we go. List object has no attribute name. So this is a really good example of the kind of error message you make when your code doesn't work. And it's actually somewhat helpful. There's a lot going on here. Again, reading backwards is the way to go. So attribute error, list object has no attribute name. Well, if you remember, when we looked at this, it happened to mention to us that this is a list of materials, and when we saw it printed out before, it kind of looked like a list. We can't just call this name thing. We would have to look at each thing in this list, and then we'd be able to find out the names of all of them. So how would we do that? So I'm going to get rid of this line for the moment, because we don't really need that. So we're going to use something called a while loop, and you're going to use a lot of while loops in Poser. They exist in lots of programming languages. Some of them I feel like are easier to use than others. In Python, it's pretty easy to use a while loop. And if what I'm saying, if while loop, what do you mean while loop? That might sound all like one word. This is what it looks like, while something. That's not a good example. So let me write out our while loop, or part of one. And then we'll talk about what's happening here. And oops, I'm just going to say less than 3. Oops, and we need this colon. This is important. And we're going to indent again. And we're going to print I. So this is not a very exciting while loop. It's not going to do anything with our materials here, but let me show you what's happening. And the reason we call it a while loop is we're telling the computer, while I, so this variable, is less than 3, print out I. So I starts out as 0, and I've nearly made the great mistake. There is a missing line, and a lot of times you'll notice I will do this first thing, so I can't forget. We're going to add one more line to our while loop, and you'll see why here in a minute. So while I is less than 3, we're going to print out I, and then we're going to take I and we're going to add 1 to it. So when we go through the first time, I is going to equal 0, and it's going to print out 0. And then suddenly I is equal to 1. We've added a 1. So then it's equal to 1, and it's going to print 1, and then it's equal to 2, and that's where it's going to stop, because 2 is less than 3, but 3 isn't less than 3. So let me show you how that looks. And I'm just going to close that. Going to run our script. 0, 1, and 2. So that got us what we wanted here. Now, I almost ran this without this line here. This is the super important line. And invariably, I'm sure at some point in doing all of this, I am going to forget to put in a line like this, and what's going to happen is Poser's going to crash. If I were doing just the print statement, it might just print out 0, 0, 0, 0, 0, and so on forever, because we're never going to break out of the while loop. And so it's a loop because we're doing the same thing over and over, and we need a way to stop doing the same thing over and over. So that's what this very important thing is for. There's other ways to break out of while loops, and we may end up looking at some of those later, but this is the most common. So what's the point of this? Why are we counting to 3? Well, we don't really want to count to 3. What we really want to count to is we want to count through the number of materials we have. So there is a built-in function to Python called len. It stands for length, and we're going to get the length of materials. And this is something that will work when you have a list. Now, this isn't quite what I want yet, but I do want to just show you what happens here, even though it's not quite useful yet, because we're still just going to get a bunch of numbers. But it turns out, actually, we have 9 materials because we started at 0. And what we're going to do now is we're going to change this to print something different. We're going to print materials dot, oops, nope, I lied. Materials I dot name. All right, so a lot going on here, but let's take a look at what happens. So we're going to run our script, And now we get stola feather, stola inner, stola, stola, so on and so forth. So these are the names of our materials. If we go to the material room and we click here, these are the names of our materials. They're in the opposite order for whatever reason. I'm not really sure why. That just has to do with how Poser prints these things. Doesn't matter. The point is we've actually been able to look at every single material in this list, every material on the figure, and print out its name. So let's go back and look. Again, I is equal to 0, and this is super important. I should not be equal to 1, and let's show you why. Let's make I equal to 1, and we're going to save, and we are going to run our script. And now, okay, well, that looks pretty good, but you'll notice here we don't have Stola Feathers. Stola Feathers is, I think it's, yep, Stola Feathers happens to be at index 0. So an index is a place in a list. It's your place in line, and computers always start counting at 0. They don't start counting at 1. Now, on that note, I here kind of like this x and y. I said earlier, don't use simple names like this for variables. This is one of those exceptions. It's not uncommon, and usually I is used because, as I was saying, it stands for index. When you're just stepping through a loop, when you're just keeping track of a number that you're going to count, you don't need to give it a fancy name. Sometimes you might, but you don't need to. So I is a pretty traditional variable name in that case. So while I is less than the length of materials, and again, len stands for length, it is a built-in Python function, and it's one that takes a list, which is what materials happens to be, and it gives you how big that list is. So when I is equal to 0, we will get every single item in that list, and we'll step through. Now, this is one of the reasons we start counting at 0 with computers, is if you think about it, actually, let's do this. Let us print the length of materials, just so we can see what it is. And we are going to run this again. And you're going to see, okay, so the length is 9, which if we count 1, 2, 3, 4, 5, 6, 7, 8, 9, we counted before, is true. And by starting at 0, we can be less than this number and still hit every item in the list. If we were starting at 1, we would have to do the length plus 1. Otherwise, we miss the very last one instead of missing the very first one like we do here. So don't worry too much about that. Just remember, you're always going to start counting at 0, and it does tend to make things easier here with statements like that. Okay, so we're going to get rid of that line. So now we've got a function that actually it does something pretty neat here. It finds the materials on the figure, just what we said we were going to. And I called it cycle through nodes. That's didn't end up quite being what this does. In fact, it kind of bothers me. I'm going to call this cycle through materials, because that's what we're really doing. So I'm going to have to rename this here. And in other cases, I might not really rename things like this, but I do want to make it readable. So cycle through materials. And so I apologize if you're typing and you're trying to copy me exactly. You're like, well, darn it, now I have to change the name. But again, we want to think through what we're doing here, and every name we give should be a way of thinking through what we're doing. So we've cycled through the materials. Well, this isn't really what we want to do. What we want to do with the materials is find out, are any of the nodes of our material the ones we want to get rid of? So how are we going to do that? Well, we can create another definition, and we're going to call this compare nodes. And you know what? Well, we'll do this. Okay, so we're going to compare nodes, and I will almost guarantee you we're going to pass something in here. We're going to pass in a material. And how do I know we're going to pass in a material? Well, if you think about it up here, so materials and I maybe didn't explain this before. In fact, I'm exactly sure I didn't. Materials I is the material at the index, at the I of 0, and then 1, and then 2, and so on. And so this materials I is one material in the list of materials. So if we end up passing in materials I, that will be one material to look at. So basically what I'm saying is in just a little bit we're going to pass this in, but we want in fact, what we could do is we could print material.name. And not very exciting, but so instead what we're going to do here is we're going to call compare nodes, and we're going to call materials I. So we're going to call the material by its index. We're going to choose first the 0 one, then the 1 one, and so on. And in fact, what I'm going to do is I'm going to do another print statement, print. We are going to say index is, and we're going to say I, and then down here we're just going to print the name of the material. So when we save and we run this, what's going to happen is this. Index is 0, stola feathers. Index is 1, stola inner. Index is 2, stola. So the index, or I, goes up by 1. It starts at 0, goes up by 1, and when we pass that into this list materials, it finds the material we're looking for, it sends it into that function, and then it allows us to print. So we've actually made two functions here. This one's still pretty basic. It's actually going to get a little more complicated in a minute, so I'm going to leave it here for now. So look through, remember, as you start to get confused, read things backwards. So here's another good example of reading things backwards. Okay, our index, so 0, is, oh, we want material 0, and oh look, we're going to compare it to a node. Well, we are eventually when we write that out. So again, we're pretty much doing everything. We're almost at logic. We're right now we've got this while loop where we've got a way to look through bit by bit a list of items, and we're going to end up doing that a lot because remember, part of the point of the script that we're writing is that we have lots of lists of stuff. We have all of that. And if we go, I guess I didn't really have to go here. We have all of this we want to deal with. So we're going to be using a lot of lists. So feeling comfortable with this while loop is really important. Understanding that we're stepping through it, that it's really important that we have a way out of it. And again, the indentations, the stuff that's indented is what's part of the while loop. All right, I will see you next time. Bye.